Teacher Freddie. So in this video, I'll be talking about my math big project for quarter 3. I'll be talking about what I learned and the standards and how I used it in real life. So if you want to keep on watching, please keep on watching, and I hope you enjoy how I explain my big project. Okay, so this is my big project for quarter 3. The title of my big project is Jessica's Amazing Big Project for Quarter 3 Math. So I'll just give you an overlook of what it looks like. So here I have what this document will contain, and also here I have some information. So introduction. This is my big project for quarter 3, and it is a Word document that contains multiple tasks that have to do with the standards that I learned this quarter. It's supposed to help me answer the essential questions as well as refresh my memory of what we have learned in quarter 3. It will also test my knowledge and my ability to incorporate the standards that I have learned and see what I have actually learned throughout quarter 3. Also, why do I think I am doing this? I think I'm doing this project because it will help me wrap up what I have learned throughout quarter 3 and help show me what I have learned and accomplished because I can do the different tasks. It's kind of like a pre-test before the exams, and it's like a revision guide to help me summarize what I've done so far. So I have maybe 2 objectives in this big project. So the first one is to be able to accomplish all the tasks and understand why I am doing it and how. So it's basically going back to the essential questions, and also being able to understand how I can use the big project math in real life. So here's just some methods to look through. And here are the results. So this was task 1, and we had to define the terms and create a figure for each. So as you can see, I have made all of the figures by using GeoGebra, and I have defined all the terms. So there are a lot of terms, as you can see. Moving on, we have task 2, which is to construct a quadrilateral and prove it is a parallelogram. So I made this using GeoGebra, and a overall review of like how to do it, it's that a parallelogram needs to add up to 360 degrees. So as you can see, all of the angles that are shown in this figure all add up to 360. And also that the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, and the diagonal bisector is congruent as well. For task 3, it's constructing a parallelogram and proving it is a rectangle. So to do this, we have to know that the opposite angles are congruent, the opposite sides are parallel, and that the 4 angles are 90 degrees. And that the diagonal bisector is congruent. So to know that it is a rectangle, we need to prove that it equals to -1. And I use the slope formula and the numbers that were given in the figure to help find the slope. Because if the slope is the same, then it will equal to -1, and -1 means that it is a rectangle. So task 4 is to draw a triangle and dilate it by scale factor 2.75. So as you can see, I have done that using GeoGebra. And I used side, side, side postulate to show that the sides have the same length and are the same proportion, as you can see. Then moving on, we have task 5, which is to draw a triangle and rotate it 45 degrees counterclockwise. So I used SAS, which is side angle side postulate, to prove that the 2 triangles are congruent, as you can see here. And I made all the figures myself using GeoGebra. So task 6 is to find the width of the following river using trigonometry. So I actually went to this river, and even though the picture shows that I'm standing on this side, I did actually measure the tree, and I also went to the other side. So as you can see, this is the tree I used. The trunk is kind of behind the house, but it is there. It is 9 meters tall, and it is 47 degrees for the point of where I'm standing. I used tan to find out the adjacent side, the missing side, as you can see. So this is how I solved it. Then task 7 is to make sure that the tree does not hit the cottage. And so the meter is 10 meters and the angles is 46 degrees from the measurements that I have found. And it is basically the same thing. I also used tan to find the adjacent missing side. So it is similar to the one that I just showed you. The last one is task 8, which is fun size cans. So there is the volume of the cylinder and the surface area of the cylinder, and we need to find the radius and height for a can that can hold 200 centimeter cubed. So as you can see, this is the answers that I got, and the radius, it's 3 centimeters, and the height is 7.07 centimeters as well. You can use different ways to find this. For example, like I know Aaron used Desmos, and I think Dan used Word Excel. I used Excel to find the numbers. And here I have the discussion and conclusion. And here's the conclusion. So after that, I want to talk about the Common Core standards. So I grouped all the standards together, and then I answered the essential questions, which are, what did you learn, why did you learn it, and how do you know you learned it? So why did you learn it? I learned the previous standards, which are GCO9 to GCO11, to prove the different theorems about triangles, angles, and parallelograms. And as you can see, I also learned a lot of math vocabulary, since this is the first thing that I learned. And there's also much more, but it's just a brief summary. And why did you learn it? I think I learned it because understanding angles will help me in real life, because we can use the angles for urban planning, building, architecture, graph theory, etc. And I know I learned it because I can explain how to do like these questions. So for example, you want to prove a theorem about the parallelogram A, B, C, D. What information are we given? And to prove that it is a parallelogram, you need to know that line AB is parallel to line CD, line AC is parallel to line BD, and angle A is congruent to angle D, and angle C is congruent to angle B. So I can explain how I know the answer. Then we have GSRT 1, and I will be explaining the essential questions until GSRT 2. So what did you learn? I learned how to dilate a figure if there is a given center and a scale factor, and using it for GeoGebra, as well as hand drawing it, doing it by hand. Why do you think I learned it? I think I learned it because if I wanted to build like a chair, I can use what I've learned from the standard to help me show the dimensions of the chair, and like what it would look like if it was on a larger scale or like a smaller scale, and how I can change the different sizes to fit my preference. And as before, I can rotate it, reflect it, transform it, both on paper and in GeoGebra. Then we have GSRT 3 and GSRT 4, all the way to GSRT 5. So in this standard, I learned how to use the properties of similarity transformations to explain how two triangles can be similar, congruent, or to prove that they aren't either. And I think I learned it because throughout all of the standards, we mainly focused on the concept of triangles, angles, lines, and proving that something is right. And by learning this standard, we can prove that we have backup, that it's not just made up facts, that it is actually true. And how do you know I learned it? It's because I can make shapes. I can use GeoGebra to show that I have learned it, and to explain how they are similar or congruent. Then we have GSRT 6 all the way to GSRT 7. So this one I grouped them together because you use sin, cos, tan for this one, and you can find the different ratios for each part of the triangle. So I learned that the side ratios in right triangles are properties of the angles in the triangles, and to find the different ratios that can be found in a triangular figure by using sin, cos, tan. And I think I learned it because you can use this in real life. For example, the one that I just showed you with the river, that was using sin, cos, tan. And I can find the missing width to see how long it will take me to get to the other side if there was a really wide river. And I know I learned it because, like I said before, I actually did the river project and I know how it works. Then we have GPE 1 all the way to GPE 6. So I think I learned about this standard because it has a lot to do with what we learned in math class. So I learned about the equations of a circle and how to find the radius using the Pythagorean theorem, and I can find the equation of a parabola if I'm given the focus or directrix. And a lot of what we did in class had to do with being able to prove if it is a rectangle or not, and being able to find different formulas and equations for certain questions. Then we have GGMD 1 all the way to GGMD 3, and I learned how to explain volume formulas and use them to solve problems. And I think I learned it because we can use those formulas for real life situations as well, such as like if I needed to find the volume of helium needed to fill up a balloon, I can do that. And I know that I learned it because I learned about the new formulas and I can do some of the word questions. And this is the last one, which is GMG1 and GMG3. So in the standard, I learned how to use geometric shapes, their measures, and their properties to describe different objects. And I also learned about density. So why did I learn it? I think I learned it because in real life we can see many different geometrical shapes, and by knowing how to measure them and find the area and volume, we can use the geometric methods to solve designing problems. So this will definitely help us in the future if we decide to design an object or structure, and we can design that object so that it withstands multiple physical constraints as well as minimizes costs. And I think I learned it because, like, for example, I know that geometric shapes can be described as real-life objects, such as tree trunks can be resembled to a cylinder, or a human torso also resembles a cylinder. So geometric shapes can be seen as in real-life objects as well. And now I just have the references that I used and explained how I used that website and how it helped me in my big project. So that was my whole quarter 3 big project. I'm sorry if it was long, but I hope you enjoyed it, and I tried to make it as fast as possible, but with as much detail as possible. So thank you very much, and I'll see you when I get back to school, Mr. Freddy.